This is a singly linked list based problem, and in this we have to reorder the nodes of the list, and we are not allowed to change the values. We are allowed to actually move those nodes. So if we have, let's say, a list like 1, 2, 3, so it's not that if we want to, let's say we want to reverse it. So in that case, we are not just copying the value and putting it here. We are actually moving this pointer here. So we have to actually move the nodes and not the values. And how do we need to move the list? Let's see an example. So let's say this is the list that is given to us. It's a singly linked list, and the results would be such that first node will be 1, its next will be the last node. So 1 we are picking from left side, 1 we are picking from right side. So 1, 5, then this left one comes here, right one comes here. So next is 2, and then its next will be the one from right. Then you move this here and you move this here, but you cannot move backward in the singly linked list. This is the basic linked list concept. So after 4 it should be 3 and it should be null. So number of nodes remain same, we just reorder them. That's why it's called reorder the list, and it's commonly asked in Facebook, Amazon, Apple, eBay, ByteDance, and a few more companies. So it looks like a popular problem. So how can we do this? So we need one from the beginning and one from the end. So I will start with a not so elegant solution, then we will arrive on a much more elegant solution. So what we will do, first we will traverse this list and store the pointers in a stack. So we store 1, 2, 3, 4, 5. These are not values, these are the actual pointers. And now its size is 5. So once we have put it in the stack, we will start from here. So current will be here at the head, and then its next. So let's store 2, we will need 2. So next of 5 is 2. So we save this into a variable called next. Next equal to current next. This we can do. And current is initialized to the head. This is head, we are not changing it. And this will remain head for the final list also. So it's next we saved. So it's storing 2, the node corresponding to 2. And then current's next is equal to top of the stack. So this is stack s dot top. And then we also pop it. So 5 is gone. And current's next is this top. So what is the state? We have 1. Its next is pointing to 5. And 5's next was null. So no other pointer changes. And 2 is separate. So 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5. And 5 is not pointing anywhere. So this is the state after this statement. Next, what we will do, current should move here at 5. So this part is finalized now. After 1 there will be 5. So current equal to current next. You don't need to use this solution. I am just writing it. It will give you some practice. And then we will also see a better solution. So stay tuned for that. So current now comes to 5. Then 5's next should be 2. And 2 we had saved in the next variable. So current comes to 5. And current next is equal to next, and next was 2. So what is the state now? Let me redraw it. So 5's next is 2, and current is still at 5. So what we can do, current equal to current next. So now current comes at 2, and let me remove 2 from here. So this is one iteration. In this what we did 1, 5, 2. So this part is finalized, and current is again here, and the next of 2 is 3. It has not changed. So this pointer we never updated. So we have to just do the same thing on this part of the list. So at the end of this loop, we are again back to the original problem with a smaller list. So again, next we will store, that is 3. So this time next is 3, and current's next equal to s dot top, that is 4. So current was 2, so its next is now 4. So next of 2 is 4. And current equal to current next. So current comes here and its next is next, whatever we had saved. So that is 3. And current comes here at 3. And then we will stop since we have added 5 nodes. So how many times we should pop it? So we will keep track of how many nodes are there. So there are 5 nodes, so we will do it 2 times. If we had 6 nodes, we would have done 3 times. So now we will stop and this loop will end. So what is the state? 1 is pointing to 5, 5 is pointing to 2, 2 is pointing to 4, 4 is pointing to 3, but 3 is again pointing to 4. So this is the extra thing that we need to take care of. So when this loop ends, current is pointing here. So at the end of this loop, what we will do? Current next equal to null, and that's it. So this is now null and we get the result. So the complexity for this would be, you can see we have done 2 traversal of the list, one for this building the stack and second for changing the pointers. So time complexity is O(n), space complexity is also O(n). But there is a better way. We can get rid of the space. Time complexity we cannot get rid of, it's expected. So you would be looking, you can see that from the stack we are popping half of the elements. That is, we are interested in the second half of the list. So in the second approach, what we will do, let's write it again. 1, 2, 3, 4, 5. So we are interested in the last 2 elements. So if we reverse it, so let us reverse it. So we make it 1, 2, 3, and then these pointers we have to change. 5, 4. So 5, then 4. So in the first part, first half, you see 1, 2, 3 occur in same sequence. That is in original order. But the later half occurs in reverse order. That is first 5, then 4, then if it had any other element. So if we reverse this part, then our job will be very simple. We have to just merge 2 lists one by one. So keep it as it is, and this we change this we make 5, it points to 4 and 4 points to 3. So we have reversed it. So now let us draw it in a different manner. We draw 1, 2, 3 and 5, 4, and it's also pointing to 3, and next of 3 is null. So this is after we reverse the later half. And how can we reverse? It's very simple. You start that slow and fast pointer concept. So slow pointer, fast pointer. Slow pointer advance by 1, fast pointer advance by 2. And as soon as fast becomes null or next of fast becomes null, we stop. So when slow is here, fast is here. When slow comes here, fast comes here by 2 steps. Then slow comes here and fast again jumps by 2 steps, that is 4, 5. So at this point we will stop since the next of fast is null. Then we know the middle of the list. So we will take this list. So just take this part of the list. So whatever is the slow pointer pointing to, reverse the list starting from there. And the reversal code is very simple. We will write that in the code. So after reversing, this will be the state. So now let's focus on this. So now what we will do, we will take 2 pointers. Let's call them N1 and N2. So how we will get 5? So we will reverse this part. Current is here, next is here, previous is null. So its next will be null. So 3 is next, we will make it null, whatever is previous. So the way to reverse is current next is previous. So whatever was the previous, we make it next. And then we will advance current equal to current next, and previous equal to, so first previous we will update, previous equal to current, and current equal to current next. So we will see that. So you must be familiar with reversing the list. It's very simple. So now at the end we will reach here and current will become null. Then we will stop. So previous will be pointing here, one node before. So previous is pointing to the last node. So that way we will initialize N2. So n1 will be initialized to head, n2 will be initialized to previous, and we have reversed it. This is the state. So our job is very simple. What we will do, n1 next equal to n2. So this is very clear, evident here. So once next is 5. So this is the answer. Once next should be 5. And after that, next of 5 should be 2. So better store it in a variable. So this is initialization part, and this is we will do in iterations. So temp is pointing to 2. Next of 1 is 5. After that, what we need to do, at the end of this iteration, we should be, n1 should be here and n2 should be here. So the problem should be exactly like before. So we move n1 to next. So n1 equal to tmp. We had stored it in tmp. So n1 is now here. Now what next? There is 1, 5, 2. And here we should have 4, 3. So n2 should come here. So let's store 4 or tmp equal to n2 dot next. So this 4 we have saved, and after that n2 next equal to 5's next should be 2. So n1 and then n2 equal to tmp. So n2 comes here. Now n2 is here, n1 is here. So this is the state after one iteration. So this part is now finalized, and we have to just work on this part. So again do the same thing. So it will be 2, its next will be 4, and n2 will come here, and n1 will become null. So we can add a condition that if n2 dot next is null, we stop. So let's write the code for this. We will write the code for both of the approaches, in fact. So now everything is pushed into the stack. So if we have less than or equal to 2 nodes, then we don't need to change anything. So if n less than equal to 2, then simply return. There is no reordering. Else we will need to do it n by 2 times. So we pop just n by 2 elements from the stack. Or we can define this outside, since it will be done again and again. S dot top. And what we had done in the end, for the last node, we had to set the next equal to null. So here in the last part, this 3 was pointing to 4. So in the end, we had to do this. So this is the first solution, and it will take O of n time and space. Then next we will implement this one. So first let's run this. So this solution is accepted, and it takes 40 milliseconds. So let's implement the other one, and we will compare if it takes less time or not. So in this, let's add a base case. If head is not there or next of head is not there, then return. It did not return anything, so just return. So slow is advancing by 1, fast is advancing by 2. So by the time fast reaches the end, slow will be in the middle. So after that, what we will do? We initialize the current with slow, that is mid of the list. And we will need a temp variable where we will save the next pointer. So you can also call it next. So we are just reversing the second part here. So this is the reversal part. So we have stored the next. Now the next of current should be previous. So whatever was the previous. Then we advance the previous to next. So the previous for the next node will be whatever is current node. So previous equal to current, and then current should also move, but we have changed the current next. But before that we had already saved what was next of that. So current moves there. It's very simple. It will reverse the second half. Then we will do the final part, that is merging of the two lists one by one. First from first node, second node from second list, and so on. So we have stored the next of first, and we will make the next of this to N2. And the next of N2 should be this one, TMP. So N2 next is TMP, but if we change this, we will lose track of the next of N2. So we will store that first. So N1, let's advance it. We are done with N1. So N1 becomes its next. That was TMP. Now in TMP, we store the next of N2. So we are using the same variable for both purposes. You can use 2 also, but the work of TMP is done till here for this part. So here we are storing N2 next, and then only we will change the next of N2. Otherwise we will lose, we will break the list. So we have stored its next and then updated its next to N1. And then N2 becomes TMP. So these two parts may look very similar, the first and second part. And the end of this iteration, one iteration, we will finalize 2 nodes, one from first list, one from second. And both N1 and N2 have advanced by 1 in both the corresponding lists. So time limit exceeded, we must be doing something wrong here. So some of the loops are not terminating. So this clearly is valid. Here current equal to current, so it should be TMP. Otherwise it will never terminate. and the solution is accepted. So this time it takes 28 milliseconds. So although the time complexity is same, you can see a better, much more improved solution here, 99.85%. Although this can be a fluctuation also. Now let's write the optimized code in Java and Python. And the Java solution is accepted. Finally, we will do it in Python. And the Python solution is also accepted.